welcome to my channel. I love physics. I'm here to make you fall in love with physics. Here I'll be uploading all the lectures related to physics, and whichever is your request, please write down in the comment box. I'll be uploading the videos regarding that. And till then, subscribe my channel, press the bell icon, and if you like it, like the video and share the video. Thank you. Hello students, welcome to the physics lecture. The physics textbook is divided into two parts. That is part first, which comprises of chapters from first to eighth, whereas chapters from 9 onwards form as part second. As your chapter from first part is completed, I'll be taking the lectures for chapter first of part second, that is optics. Before going to the lecture, I'll recommend you to keep a notebook along with your pen so that you can note down the important points while the lecture is going on. Or if you have any doubt in the middle of the lecture, just pause the video and go through your textbooks. And further, if you have any doubt, you can contact me later. So, starting with the chapter, let me first give you a brief idea about the branches of physics. Physics is mainly classified into two parts, that is classical and modern. Classical physics is further divided into thermodynamics, optics, acoustics, electromagnetism, astrophysics, and mechanics, which is further divided into statics and dynamics, whereas the modern physics is divided into quantum physics, atomic physics, nuclear physics, molecular physics, and condensed matter physics. Classical mechanics deals with the motion of objects. The statics tells us the objects at rest, whereas dynamics deals with the objects in motion. Thermodynamics deals with the interaction of matter with heat. Optics we are going to consider in this chapter. Acoustics is the study of properties of sound. Electromagnetism deals with the study of electric field and the magnetic field and their related phenomena. Astrophysics deals with the astronomical objects or the star stuff. Modern physics is based on the application part, in which quantum and atomic physics deals with the particles or the matter at atomic or subatomic level. Nuclear physics is the study of nucleus, whereas molecular and condensed matter physics are not a part of the context, so we'll skip that part. Moving to our chapter, let us consider what do you mean by optics. Optics is nothing but it is a branch of physics which deals with the light and its properties and the various phenomena of light like refraction, reflection, interference, diffraction, etc., and the study of various optical instruments like the microscope, the telescope, which you have been using in your lower standards for observing the microorganisms. Like for observing microorganisms, you must be using the microscope. And further, we'll see about what do you mean by light. Light initially was considered as a particle. Later, it was discovered by James Clerk that light also has a wave nature. So now light is considered to have a dual nature, that is particle as well as wave nature. In some phenomena light exhibits particle nature, whereas in some phenomena it exhibits wave nature. Now what do you mean by a wave? Wave is nothing but a disturbance that is created in any medium to transfer energy from one point to another point. For example, when you throw a pebble or a stone in a lake, you can see the ripples formed, that is in the form of wave. The circular waves are called as the surface waves, which are formed when you throw a stone, and they are transmitted from that point towards further points in the water. Okay, so mainly waves are of two types. One is the mechanical waves and other one is the electromagnetic waves. The mechanical waves require medium for the transmission. Medium, like any medium, it can be water, glass, or any medium. Whereas electromagnetic waves does not require any medium, that is, they can transfer in vacuum itself, that is an absence of medium. Further, mechanical waves are divided into longitudinal waves and transverse waves. This you'll be studying in your further chapters, that is in sound. Now we'll be considering what do you mean by an electromagnetic wave. So electromagnetic wave is nothing but, see here it is shown, the electromagnetic wave which comprises of two components. One is the electric wave, another one is the magnetic wave. Both the fields, that is electric and the magnetic fields, propagate in the direction perpendicular to each other. Now here you can see that electric wave propagates along the y-axis, whereas the magnetic wave is propagating along the z-axis, and the overall wave, it's propagating along the x-axis. So the electric field, the magnetic field, and the direction of propagation of wave, all the three are perpendicular to each other. So this electromagnetic waves are further classified, or this, they have a spectrum which comprises of waves from gamma rays to radio waves, but these waves are not visible to the human eye except the visible spectrum, which you can see here. This visible spectrum, only the visible part of the electromagnetic spectrum is can be perceived by a human eye. The colors ranging from violet to red, that is the colors which you see in the rainbow, that is Webster. All these colors are visible to a human eye, and all other waves present in the electromagnetic spectrum, that is gamma rays, X rays, UV rays, infrared rays, microwaves, and the radio waves, are not visible to the human eye. So all these are the electromagnetic waves, but what we can perceive, we define it as light, that is the visible light. So light is nothing but the visible light with, with the help of which we can visualize objects. Here is an example given. When you look at the rose, what happens is light is incident upon rose, and all the wavelengths except what the color of the rose is red. Except the red color, all other wavelengths of all other colors are absorbed by rose, and only the wavelength corresponding to red color is reflected back towards our eyes, and it sends signal to the brain where the information is perceived that yes, red rose is seen. This is the overall concept of visual perception, not only for the rose, for whatever object you see in your daily life. For all those things, this process takes place, but the duration or the time taken is so small that you cannot realize what has happened, or all these processes take place in such a small time that the action is that very quick, and whenever you look at object, this response is taken by the retina of your eye and signal is sent to your brain. So this was the overall introduction. Further, now depending upon the nature of light, which I said that is in particle nature and the wave nature, the optics, the overall optics chapter is or the optics is divided into three parts, that is ray or geometrical optics, wave optics, and particle nature of light. In ray optics or the geometrical optics, light is considered as a ray. You can see here, this is a ray, that is, in mathematics you have learned about light, oh sorry, the ray line. So ray has one starting point, and it moves in a forward direction in the straight line. So light is considered here as a ray. Further, there are the four fundamental laws which govern the ray optics. First one is the, which I said, light is considered as a ray and it travels in a straight line in homogeneous and isotropic medium. Now, what do you mean by homogeneous and isotropic medium? Homogeneous medium is nothing but the medium in which the properties remain same or in the overall space, whereas the isotropic medium is the properties does not change with the direction. So in all the directions, whether in x direction, y or z direction, the properties won't change, and homogeneous is the space is homogeneous, that is, there is no change in the property as you move in space. Further, second law states that two or more rays can intersect at a point without affecting their paths beyond that point. That is, as we'll see further, that when two or more rays coincide after getting passed through a lens or a mirror, there, that is the point where images form. So where the rays coincide, the images form there and they do not affect each other's path beyond that point. That is, the ray continues its motion as it was before the intersection, it will continue the same path. Further, third law is the laws of reflection. In the figure given here, there is shown the reflection of light. The arrow down shows the incident ray, whereas the upper arrow ray gives the reflected ray. What are the laws of reflection? That states that incident ray, the reflected ray, and the normal. The normal is the central line which is shown by the dotted line between the incident and the reflected ray. All the three lie in the same plane. They are all in the same plane. It may be the xy plane, the yz plane, or any other plane, but the law says that all the three lie in the same plane. And next law of the law of reflection is angle of incidence is equal to angle of reflection, which is denoted by I and R respectively. Now, you must have seen this in the earlier standards, that is, the angle of incidence and angle of reflection is measured with respect to the normal. That is, the angle of incidence is the angle between the normal and the incident ray, whereas the angle of reflection is the angle between the normal and the reflected ray. Next, fourth law of the ray optics states the laws of refraction. What do you mean by refraction? Now, the basic difference between reflection and refraction is that reflection takes place in the same medium, whereas refraction of light takes place when the ray of light travels from one medium to another medium. Now, here it is shown the white background shows the air medium, whereas the blue background, let's consider it as water medium. So light is traveling from air to water, so their refraction will take place. Now the laws of refraction states that incident ray, the refracted ray and normal lie in the same plane, same as the law of reflection. And further, the incident ray and the refracted ray are at either side of the normal. That is, normal is at the center and incident ray would be at one side of the normal and the refracted ray will be in the other side. Here the incident ray is towards the left and the refracted ray is towards the right. So they are at the opposite sides of the normal. Now further, mu is equal to sine I upon sine R, which is equal to n2 divided by n1, where mu is nothing but the refractive index of the second medium with respect to first. It is the property that shows how much a medium can refract light ray, that is given by sine of angle of incidence upon sine of angle of refraction, which is equal to n2 divided by n1, where n1 and n2 are the refractive indices of medium 1 and medium 2 respectively. So all the four laws, that is laws of refraction, laws of reflection, and these two laws, they govern the ray optics. This was the introduction of the lecture. In the further lectures, we'll be seeing what are the terms used in ray optics and reflection from plane mirror, from curved mirror. So go through the video and then read the textbook thoroughly so that we can continue the further lecture. Thank you.